I don't think Swiggy is a new name for anyone here. Our mission is to deliver unparalleled convenience to all of you and to the India beyond that Mohit was talking about. So we started off as a food delivery, but as you can see now, you're touching across every point of convenience, whether it is grocery, commerce, going out, you name it, and more to come in the future, right? So today what I'm going to touch upon is when we moved from grocery, quick commerce to everything, like everything under the e-commerce umbrella, what were the challenges a search and discovery system faced, and how the AI, the newer methods in AI, helped us overcome that and get better at it. So if you look at, sorry, yeah. So when Instamart became a everything store, traditionally how you would have solved the problem, right? Every search and discovery system were like multiple forest of models, hand-engineered features, a lot of manually tagged and manually corrected taxonomy. All of that was there here as well. But when you started expanding the whole catalog, now the job to be done of a search and discovery system was not only just retrieve and rank and show what's there, but also how do we organically enable the customer to know, oh, these are the new categories that are available on Instamart as well, right? So if you look at just when the app, if you just start on Instamart, each of the widgets have a different job to be done. When you look at something like Quick Picks, it's a very exploitation heavy and less of exploration discovery. You want to come there, get something quick. So it's a very high intent one. Whereas when you go into something like a category widget ranking, different categories you're showing on Instamart, there it's to enable more discovery to say, oh, Instamart has medicine also now. How will the end customer come to know? And then when you move on to something like overall ranking in a particular category page, it's a mix of high intent as well as enabling discovery. So we were thinking, instead of looking at each of these as different problems, can AI really enable us to say, can I build something fundamental? Can I build something foundational that can enable across these use cases? That's the thought process it started with. Then, of course, search. Search is a very high intent where customer knows exactly what he or she wants. It's a very high intent one. So if you have to enable discovery there, it has to be very silent, organic, and complementing to what the customer is looking for. For example, if you're looking for bed sheets, can I really organically show you I have different kinds of bed sheets? Or can I show a theme to say, OK, now you can have your home decor as a theme, which is complementing to what you're looking. You're also informing the customer and bringing that awareness while not deviating from that high intent touch point the customer is at. There are other areas also, which if you think of like other job to be done, when you're looking at a product, you have to show similar items to say, I have more variety in this item. There are certain hand-picked honey that you can look for. So this also has some model powering it at the back end. There are more, when you're adding an item, how can I say, this is also frequently bought together with it. When you're buying bread, there are eggs, cheese, butter that you're buying along with it. And the last intent is when you come at the end of your journey, almost at the cart, you're saying, did you forget? And you're enabling the completion of cart for the end customer to say, these are the other items that you might have forgotten and you have to add it to your cart, right? Now, roughly that kind of lays out what are the different areas that search and discovery has to really satisfy for the end customer. So let's look at the journey we took to enable this. So we'll start with search, right? We also started off at a point where search was a lot of keyword and fuzzy matching of strings, and then a lot of manual annotation of the catalog, tagging, the taxonomy. We started our journey there. Of course, when we started off Instamart, it was a third party we started with, right? And I think we took this journey maybe 1.5 years ago to say, can we build something internally where we can enable semantic search? That was our first step towards it. And when we say semantic search, can we understand our customer can we understand our products and match them much more better than just looking at what the keyword the customer is searching for. So this was our first step towards enabling semantic embeddings for our products and the queries that the customers are asking for. So what we started off here with is a transformer-based architecture model. So we started off with a warm start, where in the first place you are saying, can I really just understand my catalog better, right? Before I come to what's the query, what's the product. Just like how language models understand the language and hence get the world knowledge, can I just get the knowledge of the catalog that we have on Instamart? So what did we do? We created the first part of the training, very easy to learn kind of matchings. For example, let's say I take queries, and I pick top 80% of the products people had converted on that query. And I just train this a shared parameter transformer architecture, and I can encode this whole language of the products and the queries. So if you look at, for example, just how we tokenized it, there is a query, somebody is looking for tur dal, right? So how can I add more information about the product itself to say there is a brand, there is a category that it belongs to, there are multiple levels of subcategory, category it belongs to. Can I just make my model understand this? So can I just train this warm-up training, just giving this data, and it's a shared parameter encoding. Now once I do this, of course we used a MNR loss there. It helps that contrastive learning to say, which are the right good pairs of queries and products that people have converted on. But this itself isn't enough, because if you look at all the products, 80% of the products people have converted on, here you have just understood the catalog. The model has just understood the domain of Swiggy's catalog, right? Now what we did is a curriculum training where we said, now we have got some encodings based on this. Now can we just decouple it? Now I'll go to the second stage of model training, where I decouple the product and the query. And here I give more tougher to learn examples. By that what I mean is, of course, when we sample the negatives, I'll sample in a more self-adversarial manner, where you have to really distinguish, is this what customer is asking for? And even in terms of the queries and products you are learning on, we made sure it is sampled right to kind of model what customers really choose when they are querying for something and what they don't choose. So this is, you can think of like a further fine-tuning of the base encoding you have got, and you can learn the product and query embedding separately. So this enabled us, it's kind of now here you have decoupled the query and the product. So this enabled us to get some level of semantic understanding of what customers are looking for, what products we are showing them, right? So this enabled us that, but there were some drawbacks here, right? Some of the drawbacks were, of course, it is kind of tightly coupled to whatever we have in the catalog. How much ever we also augmented the data with data from GPT and LLMs to say, let's say somebody is looking for one brand of running shoes. Can we augment the data and say, it can also map to these other brands, and even if you don't have one thing in the catalog, can we show something relevant to the customer? That level of out of catalog we were able to manage, but as we were expanding the category, there is more and more just out of vocab words coming in, and more categories coming in, which means we really needed the world knowledge in these encodings for us to enable the discovery for the customer. So that's where our journey from a very small language model to a small language model began, right? So here what we did is, can we pick some open source, embedding models, a small language model, and fine-tune that, because there is some level of world knowledge already available, and can we fine-tune that based on this catalog? Just replace the encoding or the warm start that we had with this open source embedding model, and then fine-tune it to see how well we can do. Of course, one advantage this also brought us is, earlier maybe we were dealing with like a 64 size embedding. One advantage this brings us, it of course expands the embedding space itself, the dimensions of the embedding space, but it also has a trick, what we call as the Matryoshka, some of you would be aware, which is whatever knowledge you have in, let's say, 758 size, 768 size embeddings, can I learn it in a nested manner? By that, what I mean is, I'm training multiple losses to say, in a 64 size embedding, can I capture everything? Then, in a bigger size embedding, can I capture all the knowledge? So it's learned in a nested manner, so that when we are deploying it, because search is a very low latency, high throughput case, when we are deploying it to handle scale, can we use smaller size embeddings and still be able to capture that learning? So I think this movement from a very small language model to a small language model, it brought in much more versatility. The variables embedding dimensions helped us handle scale and deployment in production, and brought in that world knowledge we were missing. So just to give an example, earlier when somebody searches for Catan, I don't think the model was able to get that it's a game, right? That's world knowledge. Now when somebody is looking for it, we were able to see that after this change, you are able to understand the intent that somebody is looking for a game and throw more relevant results for the customer. So that's the journey till the small language model. Then the next challenge we faced is, of course, customers are very creative and innovative. We also saw queries where people came and said, I had a breakup today, right? So people are getting more conversational. I think ChatGPT has trained people to get more conversational. And very complex and varied queries customers were coming with when we analyze, which are the queries where we are not able to get relevant results for the customers. So we thought, how can we even enable the conversational, more complex and more descriptive queries of end customers, right? So that's where I think our journey from the small language model to the large language model began. Of course, you cannot put this on every path to the customer, so we had to get choosy in terms of when will you enable this and when will you not. And of course, it comes with a higher latency, and how do you creatively handle that on the user interface for the end customer, right? So here, some of the examples are, like people are asking, soft detergents for a very sensitive skin, or eco-friendly detergents for a sensitive skin. Or somebody is asking a family-size cooker with timing, right? Or some people give very attribute-rich queries also. They say, running shoes with good support less than 3,000 rupees. And some people say, bhagne ke liye juta, right? So there is the entire variety. So one thing we should enable here is, how can we first of all decide when to just go to your regular search and when should you go for your conversational search? That itself is a decision. But even when you go for your conversational search, what are the steps we need to do? There are certain queries where maybe you need to do a named entity recognition. There are certain queries where you might have to just expand the query to say what it really means and get the true intent. And then you have to add some words as tags. If you do that, then your regular search will be able to retrieve much more relevant products to this. So what we used LLMs here is to augment that so that we can route that query to the same backend engine we were using earlier. And that, of course, after that, when you rank also, you have to take care of the fact that is it matching the attributes customer was looking for. For example, in what I'm showing here, you can see the ARC support is highlighted, right? So that's the right attribute to be highlighted. So in a dynamic manner, you can show up relevant results to the customer, highlight contextually the relevant tags that the customer is really interested in. So this is where our journey from the SLM to LLM helped us get better in the conversational search bit, right? Then the next question we asked ourselves is, OK, this is the journey, but can we build something foundational, some notion of a foundational model for our personalization based on this, right? So that is a journey from the LLM to our own foundational model for personalization, which will have a rich understanding of customer behavior, our catalog, etc. So here what we did is just to draw the parallel to a language model. Every interaction of the customer on the app is like a word, right? They are interacting with a particular product. So a product embedding is like a word embedding there, right? And there is a sequence of actions the customers are taking. And at the end, you order. That's almost like an end of sentence, right? So can we use that notion to get the understanding of what do customers do in sequence? And if you're really able to get this, then we can build something foundational that can be used across these use cases. Because everything is a next action that way. Like, if I'm going into a category page, I'm adding one item, there is a sequence of items I'm going to add next. Or I'm at the cart and you want to say, did you forget? It's the same sequence of items you can use there. Even on search, after you add one item, it's a sequence of actions you're going to take. So that was the initial thought process. So our first attempt here is, we used this notion, and we trained a multi-headed attention model, a decoder-only model, on the sequence of actions the customer have taken, of course, with a small context length, right? So here what we realized is the difference between English and the actions customer take is that in English, there are a lot of these popular stop words that we have that are actually needed when you're generating the sequence. But when you're generating a sequence of products, it gets hugely biased by the popular items, and you don't want to do that. The whole idea is to improve the diversification and discovery of new categories. So of course, it needed some level of post-processing to say, how can we change the sampling so that we downsample some level of very popular items that might show up everywhere. How can we bring in some angle of what the customer has already ordered, and in the re-ranker part, can we handle a mix of next actions plus what that specific customer has ordered before, right? So some of this post-processing was needed, and we had to increase the temperature to bring in more exploration. But this was a good first step for us to move towards something foundational. Of course, there are drawbacks here that we still have to solve for, which is, OK, before I go there. So the way we imagine this is multiple use cases, whether it's the next item on the cart completion, we are using it for multiple use cases. Next item during your item, after you add, there is a series of items that show up as this is frequently bought with this. And your next item on the search result. So multiple use cases where one powerful model can enable multiple adapters or multiple use cases for the end customer. And the product encoder can be used for your similar items retrieval that we were talking about earlier in an example, right? So when we think of what next, there are certain drawbacks in this, right? Because we have learned this on all customers in a general behavior of all customers. It's not very personalized at n equal to 1 level, right? So one definite next step is, can we really say, can we get a hidden state for a customer based on that customer's specific historic actions, so that we can make it more personalized for that particular customer? Second, we are only predicting next item. So can we get into a more multi-horizon prediction, next 10 items kind of prediction? But also, one more thing is, even with the foundation model, we are still predicting what's the next item, which again brings back to the same thing, that can you go beyond your catalog, and is it adaptable for out of vocabulary as you expand your assortment? So one of the things we want to try here is, can we actually predict intent by coming up with a good ontology for what intent means, right? Every customer comes with an intent, which could be a query, which could be some category or kind of item you want to buy, but not necessarily the exact item, so that we can surface more and more as we build our assortment. So can we get into next n intent prediction is the direction we are thinking of here. So of course, here, the approach that we are trying, this is still in development, and I don't have results to show here. But this is something where, for the customer, can we get something foundational? And we want to include series of actions, not just products, right? Every action that the customer did, you viewed something, and maybe you liked something, and you added something to cart, you searched something. Every action, can we come up with the right intent definition and the ontology for that, and use every action as a sequence of actions for the customer, and then build adapters for different use cases that I was talking about based on this foundational model, and hyper-personalize it for that customer, right? So this is where we are. In terms of what comes next, I think today you should all Swiggy. It's Friday weekend. Just showing one example here, which is also what language models have enabled at the back end by really enriching your catalog in a very contextual manner. By that, what I mean is, earlier it involved a lot of manual tagging to say, when somebody is looking for carrot and they're trying to make carrot halwa, right? You can almost realize that that is the intent. You can map it to different sets of themes and then generate, a cart page that you can add. This can be applied across where you can develop very contextual themes based on the customer. For example, I'm a huge Bollywood buff, and if Instamart comes up and says, given you are a huge Bollywood buff, here is dialogue bazi cards for you, I'll be very delighted as a customer, right? So how can we come up with more natural language explanations for what we are recommending that is customer-centric than very templatized? Historically, if you see before, because you searched for, because you added this to the cart, very templatized explanation of recommendations. But what LLMs can enable for you is, based on the customer history, get a very natural language explanation of that customer's taste. And can that be used to explain your recommendations for the customer? So at least I see where AI is taking us in the personalization and the discovery journey is, first of all, I think it's getting super hyper-personalized. And the surface itself of interaction for the end customers is going to change. Some are saying conversational, some are saying voice, and some are saying more like, rather than retrieval, it's more generated pages for every single customer. So it's a big journey I think we'll take as we are doing this. And hopefully you'll get to see some of that on the Swiggy app too. So that's where I'll stop. Thank you.